Okay, in this video I'm going to be providing a couple examples about scales. You're going to have to bear with me here. I've got my camera set up at a kind of a funny angle, so you might not be able to see at all times while I'm recording. I'll try my best to keep everything in view though. So before I do a few examples here, a couple things to keep in mind about scales is when we're reading a scale of like this scale here, we've got 1 inch equals 30 miles. I want to keep in mind that that is talking about paper scaled to reality. So just keep in mind whenever you're looking at a scale ratio that paper is on the left and real is on the right. So if 1 inch on paper is 30 miles in reality, we know that real is clearly much bigger than paper. So this is going to be, paper is going to be much smaller than the actual object. Vice versa, if we have something like down here, we've got a scale of 2 inches on paper equals 1 inch in reality. We know that this is a double scale because paper is bigger than reality, so it's going to show up larger on the paper than it is in real life. And the other thing to remember is you need to let the scale basically do the work for you. Don't try and do any math or anything in your head. Just make sure you're using the right scale and you'll be able to read the numbers directly off the scale. So that being said, I'll get started. I'll do a couple examples. So the first one that I wanted to do, I want to draw a line here that is 3,880 feet, and the scale that I want to be working in is 1 inch equals 600 feet. So since I've got a scale that starts with a nice multiple of 10 starting with a 6, I know that I'm going to be looking for my civil engineering scale. So on my engineering scale, I'm going to come over here and I'm going to find my 60 scale. So I'll go ahead and line that up. I'm not sure how well this is showing up. Okay. Let's see. Might have to do this. If I do this upside down, that'll help. Okay, so I got my 60 scale. We can see what I'm doing here with 60. And I'm looking for a line that is 3,880 feet long. So, since I know that 1 inch here is 600 feet, if I were to draw a line that is out to, hope this shows up, if I were to draw a line out to the 6 here, where that cutoff is at the 6, I know that that line on paper is 1 inch. But I know in reality, that's actually 600 feet. So since I'm drawing a line that's almost 4,000 feet long, it's going to be considerably longer than that line. So I'll erase that one. Okay, so here we go. I'm looking for 3,880 feet. So I'll line my scale up here. And I'm going to come out to, I have to move it over so everything's in view. There we go, there's my 38. Okay, so I'm going to bring the line over here to 38. And since I'm going up to 39, I'm not quite going to 39, I'm going to 3880. To keep myself 100 feet, 20 feet shy of that next 100 foot mark, I'm going to go out 4/5 of the way there. So I can use the marks that are on the paper to carry out the remaining 4/5 of the distance between 38 and 39. So I'll just go out. So it's divvied up into 10 marks here. So I can just come out to the 8th one. That's 4/5 of the way there. There we go. Close off that line. So now this line I've got, where to go? So this line I've got is, with a 1 inch equals 600 foot scale, is 3,880 feet long. Okay, so the next one I'm going to do is a line that's going to be 3 feet 10 1/4 inches, and the scale that I'm selecting is 1 inch equals a foot. So with a 1 inch equals a foot scale, since since that is a ratio of 1 to 12, that's not going to be very nice for my engineering scale. So I'm going to grab my architect scale instead, and I'm just going to use my 1 scale here. I'm choosing a 1 scale because I've got both my paper and real scale sizes start with a 1, so I think that's going to be units working out nicely. Okay, I'm going to have to flip this upside down again so we can see. So I'm going for 3 feet 10 1/4 inches. So my scale is 1 inch equals a foot. So I know that every inch, so every inch here, distance this way is 1 foot in reality, and I'm looking for almost 4 feet. So what I'm going to have to do, since I'm working with the big marks here, you can see there's 2 sizes of marks. There's the slightly taller and the slightly shorter. We can see that on the other side of the scale I've got a half. So the half scale is working with the smaller starting place and going this way. You can tell that by the numbers counting up. I've got 0, 2, 4. On my other side I've got the 1s starting this way, 0, 1, 2. So I'm only going to pay attention to the big marks here, and then I'm going to have some spare change left over. So I know it's going to be, my line is going to be almost 4 feet, but not quite. So what I need to do is move my, what's called the spare change here, or that's what a lot of us call it, including Karen. I'm going to use my spare change to get that remaining 10 inches and a quarter. So, since I know that this part of the scale here is divided up, there's 3, 6, 9, 12, it's divided up into nice 12th increments, I can go ahead and slide my way over here. So that would be, if I were to stop here, I would have a line that was, and I mark out to the end of the line here. If I were to draw a line from the beginning to the point where my pencil is now, I would have a line that was 3 foot 6 inches, but I want a little longer than that. So I'm going to come out to 9, there's 10, and we can see that between the mark for 10 and 11, it's divided up into not quite 4th increments, but for the purposes of our drawing at this point, we can go ahead and just sort of, oh, I changed my mind, it is divided up into 4ths. So I'm going to come out one more of those, the smallest mark. So there's a quarter. So that's a 1/4 inch. So each one of these bigger marks here on the 12th, we're considering 1 inch, and then it's divided up into quarters between that. So now I'm at, here's 3 feet. So I'll go ahead and draw my line. There we go. So that is, there's my 3 feet, and then from the spare change I got 10 1/4 inches. Oh, and what I haven't been doing so far is marking the other end of my line. So I drew line K, L, and Q, R. Okay, moving on to the next section. So we're going to measure this line using these different scales listed here. So the one I'm going to measure with is 1/8 of an inch equals 1 foot. This is another, you can always tell from units that are inches and feet. We know that's going to be an architectural scale. Engineers don't like going back and forth from inches to feet in fractional units. So what we're going to do is use our architecture scale. So this is an easy one, starts with 1/8 of an inch. So I'm going to use my architect scale and find the 1/8. There it is. I'm going to have to do it upside down again, so it will show up on the paper. Okay, so I'm going to measure this line. 1/8 of an inch equals a foot. So I'll start with 0, and we know that since 1/8 of an inch is on this side, the 0 mark is a little shorter. So I'm working with these shorter lines. So there's 4/8, and since 1/8 of an inch equals a foot, that would be 4 feet, 8 feet, 12 feet. Okay, so we come out to the end. Conveniently enough, we don't have any spare change here. The end of our line lines up exactly with one of the marks on the paper here. So I've got, come out to, so 1/8 of an inch equals a foot, so every one of these little small dashes here is a foot. So there's 44, 45, 46, there's 47 feet. So I'm going to record that this is 47 feet, 0 inches. I guess that didn't quite show up, so I'm just recording 47 feet, 0 inches. Okay, that's pretty straightforward. Next page here, we've got sort of a variety of geometric figures. I'm going to go back to my civil engineering scale for this one. I'm using 1 inch equals 40 feet. Since it's a 40 and there's no fractions or anything, I know I'm using my civil engineering scale. So I'm going to find my engineering scale, the 40 scale, and I'm measuring the distance across this gap here. So hopefully we can see. I do apologize for the strange angles I'm rotating things at, but just trying to keep everything in the picture. So it looks like if I keep one point at one end, so 0 is at this end, I'm lined up exactly with the 8 here. So we know that 1 inch, so we come out to the 4, that would be, an inch in paper goes from 0 to the 4 here. We know that that's 40 feet according to our scale of 1 to 40. And since this is 2 inches in reality, come out to the 8, so that's 80 feet. So the size of this dimension is 80 feet. Another way good way to think about scales is if you've ever taken physics or chemistry or even some math courses using dimensional analysis, think of this as a conversion factor. So if I know that in reality I could measure with just my normal ruler, like my 16 ruler on my architect scale, I could say, hey, that's 2 inches in reality. So I could say this is 2 inches, and I want to go from inch units to feet. So I'm going to use my 1 inch equals 40 feet as my conversion factor. I'm trying to get rid of my inch units, so I'll put that on the bottom, and 40 feet goes on the top. So my units of inches are going to cancel out, and I'm left with 80 feet. So great, that's the same thing that I measured with my 40 scale. So just, you can double check yourself if you're not sure on one. Double check the math using this sort of dimensional analysis style if you want. So size, this is asking for basically the scale of the units. So first of all, ruler, I know I'm using my engineering ruler. Type, that's 1 to 40 is generally a civil engineering scale. 1 inch equals 40 feet. If you're down into the lower values, something like tenths of an inch or something, small values tend to be usually mechanical engineering scales. But bigger ones like this, going from inches to feet, with nice round numbers like 30 or 40, it's going to be a civil engineering scale. So my size, sort of figuring out the scale all in the same units, I've got 1 on paper is, so that would be, since I'm working in inches here, I'd multiply 40 by 12, that would be 480. So the size of this scale is 1 to 480. So anything I draw on paper here is 1/480th the size that it is in reality. Just keeping in mind that this is paper real. Units for, let's see, I gotta remind myself what units is asking. Oh, right. So all this is asking is what units is my scale going from. So this is going from, is that right? It's been a while since I've done this packet. Well, guess for now I could be wrong, so double check this with Karen, but for now I'm just going to put my units are in feet and inches. Okay, so I'll do one last example on this page here. So these ones, these objects here and the buildings are asking you to find an appropriate scale to measure. We know that this, I'm not sure if this is a doorknob or what, this doorknob shaped object is 3 inches. So all of them are going to be 3 inches, and then the building we have a dimension of 25 feet. So we've got 4 different sizes, and we're going to find an appropriate scale for each one. So I'll start with the first one. So 25 feet. I'll go ahead and try an engineering scale. Why not? So if I take a 40 scale, let's see. So that's, oh, that's pretty close. That's dead on. Got kind of lucky there. So, okay, 40 scale works. I happen to know from when I was looking at it earlier that another scale works. So either would be appropriate. So 40 scale, keep in mind that if I'm saying 1 inch equals if 1 inch equals 4 feet, then every one of these, sorry, not showing up on the video again. If I'm saying 1 inch equals 4 feet with this scale, then that means that every one of my big marks here, so there's 2, that's 2 feet, 3 feet, 4 feet. So this is an inch here from 0 to 4 in reality, but with the scale of 1 inch equals 4 feet, that would be 4 feet. So I can come out and I know that if I line up 0 at the end, this lines up with 25. So I could say that I'm going to use a scale of 1 inch equals 4 feet. Another scale that I know would work actually is it's the same size. If we convert this really quick, 4 times 12 is 48, so we know that this scale is a size of 1 to 48. So everything we draw on paper is 1/48 the size it is in reality. Another scale that actually has that same size is the 1/4 inch scale on the architects. So I'm using my 1/4 scale. And if I line up with 0 here, if I count out, and I'm counting the larger marks since I'm starting at the larger 0 tally. So there's 2, 4, and again I'm considering 1/4 inch equals 1/4 inch equals a foot. So every one of these is a 1/4 inch in reality, a foot with the scale. Okay, so we come out here and look at that, we line up with 25 again. So I could have also said that 1 inch or 1/4 inch equals 1 foot 0 inches. So this is on my engineering scale. 1 inch equals 4 feet on my engineering scale, or a 1/4 inch equals 1 foot on my architectural scale. And you'll notice that these are the same ratio. I just essentially with the architect scale I reduced both sides by 4. And again, they're both the same size of 1 to 48. So that was just a few examples of scales. I hope that helped, and again I apologize if you had a hard time viewing this video from things rotating around and not necessarily being in the frame.